Okay, let's talk about Chapter 3, Section 1. So we're basically delving into decimals. We're going to be able to write decimal numbers in words and translate words into numbers, add and subtract decimal numbers, and solve practical problems involving decimals. So by now, you know that whole numbers are written in a form based on powers of 10. So 237 means you have 2 times 100, because you've got 2 100s, you've got 3 10s, and then you've got 7 1s, or 200 plus 30 plus 7. Well, a decimal number is a fraction whose denominator is 10 or more, is 10 or some power of 10, such as 10 or 100 or 1000, and so on. A decimal number may have both a whole number part and a fraction part. Here's an example. So we've got 324 and 576 thousandths. Okay, and we know how to deal with the 3 times 100 because it's in the hundreds place, the 2's in the tens place, and the 4 is in the ones place. But when we go this way, we've got a decimal, so we've got 5, and then that's the tenths place. The 7 is in the hundredths place, and the 6 is in the 1000ths place. So we're familiar with money. So if you are already familiar with the way of interpreting decimal numbers from working with money, well, then you know that if you've got $243.78, you've got 2 $100 bills, you've got 4 $10 bills, and you've got 3 $1 bills. And I know this could be broken up a little bit different depending on what your currency is, but in our number system, this is how it would go. And 78 cents. Well, the 7 represents a tenth. The 8 represents 100. There's 100 pennies in a dollar. There's 10 pennies in a dollar. So writing a decimal in words is not too complicated. So we've got our ones place and then our decimal, tenths, hundredths, thousandths, 10,000ths. So if we've got something written in the first decimal place, so if this says 0.6, then we know that we don't have anything after that, and 6 is in the tenths place, and so we would read that 6 tenths. Okay? The next number says 7.05. So we've got our 7. The decimal is always read and then we have 5, and 5 is in the hundredths place. So that's why we say 7 and 5 hundredths. If we were going to write it as a fraction, they've got it written over here. 12, right? We know this part. 12, the decimal part, is always and then we've got 267. Now, how did we decide that this was the thousandths place? Well, when you come up here and you write the 267, because our decimal was right here, the 7 determines what the place value is, and it's in the thousandths place. So on this one, we wouldn't say and because there's no number in front of the decimal, so we would just say 65, and then we need to decide, since this is decimal 0065, the 5 is in the 10,000ths place, and that's why they gave it that term. Okay, we usually write a decimal number less than 1 with a 0 to the left of the decimal point. For the previous example above, we had 0.6, but we wrote it 0.6. These two things are exactly the same. We just usually see it like this. 0.0065 is written 0.0065. They write that 0 in the front to hold that space. But both of this number and this number are exactly the same. It's easy to and they do that because it's easy to mistake 0.6 for 6, but this makes it a little bit more clear when you stick that 0 in front to not overlook that. decimal place. The word and represents the decimal point. Everything preceding and is a whole number part, and everything after and is the decimal part of the number. So to write 624 thousandths as a numeral, first you're going to write the whole number part, which was the 6, and then you're going to put a decimal after it. Next, draw as many blanks as the decimal part indicates. So in this case, the decimal part is thousandths, and if we go and look up here, back to our thousandths, tenths, hundredths, thousandths, there would be 3 spaces for that. And so they drew 3 decimal places. Then it says write a number giving the decimal 24. Write it so it ends on the far right blank. So they wrote 24 because they knew the 4 was in the thousandths place. Then you have to go back and fill in the missing spot with a 0. In the decimal number 86.423, and we would read that 86 and 423 thousandths, because this is the tenths, hundredths, thousandths. The digits 4, 2, and 3 are called decimal digits. The number 43 and 6,708 10 thousandths has 4 decimal digits, 6, 7, 0, and 8. The number 5,376 and 2 tenths has 1 decimal digit, which is just 10. All digits to the right of the decimal point, those that name the fractional part of the number, are decimal digits. Talk about the decimal point. We will use the idea of decimal digits often in doing arithmetic with decimal numbers. The decimal point is simply a way of separating the whole number part from the fraction part. It is a place marker. In whole numbers, the decimal point usually is not written, but it is understood to be there. So we would write 2, but we know that that's 2, and then there's automatically a decimal. It's just understood to be there. 324, we could also write it 324 with a decimal after it. Very often, additional zeros are attached to the decimal number without changing its value. For example, 8.5 is equal to 8.50, or 8 and 5 tenths is equal to 8 and 5 tenths. And you can add zeros on forever and it's going to be the same number. 6 is equal to 6, which is equal to 6. You could keep on adding zeros on the end. It doesn't change the number. So let's talk about expanded form. Writing decimal numbers in expanded form will help us understand the addition process. The decimal number 267 thousandths can be written in expanded form. So the number in the tenths place would be 2 times 1/10. The number in the hundredths place would be 6 times 1 over 100. The number in the thousandths place would be 7 times 1,000. The decimal number 23 and 526 thousandths can be written in expanded form. So we've got 2 times 10, 3 times 1. This is and, right? 5 is in the tenths place, so 5 times 1/10. 2 is in the hundredths place, so 2 times 100. 6 is in the thousandths place, so 6 times 1,000. And we could simplify that by writing it like this. Go ahead and multiplying each one of those steps out. So they've got a nice little table down here that kind of helps you if you're struggling with this a little bit. So we've got several examples of how they've broken these numbers down. Because decimal numbers represent fractions with denominators equal to powers of 10, addition is very simple. Using expanded form, we can illustrate it this way. So they've broken it down and written it as fractions, and you can see how they've added the fractions together, and that's how they came up with the answer. So like 4 100ths plus 3 100ths ends up being 7 100ths. So let's do a couple of examples of addition. So if I have 1 45 hundredths plus 3 42 hundredths, you want to make sure your decimals are lined up. And then you want to follow the regular rules of addition, just like we were doing before. You would do 5 and 2 is 7. 4 and 4 is 8. You would bring down your decimal point that's lined up. 1 and 3 is 4. And that's how you would get your final answer. 13.2 and 1.57. The tricky part about this is to make sure our decimal point is lined up. And also, it would maybe be helpful to stick a 0 here. We can always add zeros to the ends of the numbers to make sure that we've got something so it's not confusing with the nothing being there. 0 and 7 is 7. 2 and 5, 7. 3 and 1 is going to give you 4. And then we would bring it down our 14. So 14 and 77 hundredths would be the answer. So an automotive technician might be paid by the flat rate method. This means that he is paid for the number of hours that each of his jobs should take, and not by the number of hours he actually works. In a particular week, a technician's daily flat rate hours were, and they've got these listed here for us. How many total hours of the flat rate did the technician accumulate? So I'm going to kind of come over here where I've got a little bit of room. So I see 8.75, and remember you want to keep your decimals lined up. I'm going to add a 0 just so I've got that extra place. You don't have to do that. 9.4, 7.75, and then we're going to add our 8. I'm going to add 2 zeros after that just so I can make sure I keep that lined up. So 5 and 5 gives us 10. We would put the 0 and carry the 1. Okay, 7 and 8, and then 7 plus 1 is 8. 8 and 5 is 13. 13 and 4 is going to give you 17. 17 and 7 is going to give you 24. We're going to put down our 4 and carry our 2. 2 and 8 is 10. 10 and 6 is 16. Plus 9 is 25. Plus 7 is 32. Plus 8 is going to give us 40. Okay, so we've got 40 and 4 tenths. So 40 and 4 tenths. We don't really need that extra. We don't really need that extra 0 here. Okay, let's talk about subtraction. Subtraction is not a lot more complicated, but if we've got $437.56 and we want to subtract $41, remember that we need to keep our decimals lined up. You could go ahead and put 2 zeros here if you would like. That would make it a little bit easier to look at, I guess. So 6 minus 0 is going to give you 6. 5 minus 0 is 5. 7 minus 1 is 6. Now I can't do 3 minus 4, so I'm going to need to do what I was doing earlier when we were dealing with whole numbers and borrow from the 4, make this a 3, and so that's going to turn into 13 minus 4, which is 9, and then we're going to have 3. So $396.56 would be the answer. So if we do 19.4 5, 2 are 19 and 452 thousandths, and we subtract 7 and 3,617 ten thousandths, you're going to need to put a 0 there to hold that place. So when we subtract, we can't do 0 minus 7. We're going to need to borrow from this 2 and make this a 10. 10 minus 7 is 3. We're not going to get anything here because 1 minus 1 is 0. We cannot do 5 minus 6, so we'll have to borrow from the 4. Make this be a 3. So 15 minus 6 is 9. 3 minus 3 is 0. We can do 9 minus 7, that's 2, and bring down our 1. So our final answer would be 12 and 903 ten thousandths. Okay. Moving on to our last couple of examples. If I want to do 36, remember our decimal would be here, minus 11.132. Probably going to want to put zeros here to hold these places. And we know we can't do 0 minus 2. So we're going to have to go all the way over to the 6 and make this a 5. And remember, this would make this be a 10. We would borrow from it, make it a 9. That would make this be a 10. We would borrow from it, make it a 9, and make this last one a 10. So 10 take away 2 is 8. 9 take away 3 is 6. 9 take away 1 is 8. And we bring down our decimal. 5 minus 1 is 4, and 3 minus 1 is 2. So we would end up with 24 and 868 thousandths. Okay. In 2012 Summer Olympics, Gabby Douglas of the United States was the all-around champion in women's gymnastics. Her routine on the uneven bars had a maximum value of 16 and 6/10 points, and the judges assessed her at 867,000 points worth of deduction. So what was her final score in the event? Well, deductions mean that they're going to mark off her score, so we're going to need to subtract those things. Okay, so we know we can't do 0 minus 7, so we're going to have to come all the way over here to the 6 and make that a 5, make this a 10, that's going to make it a 9, and then we can have this whole thing be a 10. So 10 take away 7, 3. 9 minus 6 is 3. 5 minus 8, we can't do that, but we can borrow from the 6 and make it a 5. 15 take away 8 is 7. Bring down our decimal. And so 15 minus 0 is 15. So her score with the deductions would be 15 and 733 thousandths. So that is it for Chapter 3, Section 1.